Hello, Matt G4IYT here, and today we're looking at the full license mock examination number 1, version 1.6, and we've reached question 16, which reads, in the field effect transistor, the pinch-off voltage is the bias required on the A, gate to reduce the drain source current to 0, B, drain to reduce the gate drain current to 0, C, source to reduce the gate source current to 0, or D, source to reduce the source drain current to 0. Why don't we start off by drawing ourselves a little picture of a MOSFET or field effect transistor, or rather the schematic symbol for it, and just remind ourselves what it does and how it works. So it is a 3-terminal device. We have a gate, we have a drain, and we have a source. That's an S, not a 5. And typically a voltage applied at the gate can be used to control the flow of current from the drain to the source. That's in the conventional direction. So we can go through some of these answers and see if any of them make sense, just based on what we know from this symbol. So let's look at D. So the pinch-off voltage is a bias required on the source to reduce the source drain current to 0. So we're talking about applying a voltage here to reduce the current that would flow from source to drain, but as we've already discussed, we apply a voltage at the gate to control the flow from the drain to the source. So that doesn't really check out with what we know. Let's strike that one off for now. Is the pinch-off voltage the bias required on the source to reduce the gate source current to 0? Well, again, we know that we typically apply the voltage at the gate, but there's another reason why that may not work. And if we look at the symbol here, we can see it looks almost like there's a capacitor in here. And actually the way that these devices are made is that there is a thin layer of silicon oxide, and so the gate isn't directly connected to the drain and the source piece. There is a small capacitor here, and so it acts like there is a capacitor here. And because there's a capacitor here, we can't have current flowing from the gate to the source. That is unlike the BJT, the bipolar junction transistor, where you can have current flowing from the base to the emitter, but we don't see that with field effect transistors. So that also doesn't really check out. Let's cross that one out as well. Is it a voltage applied at the drain to reduce the gate drain current to 0? Well, for the same reason that we don't see a gate source current, the capacitor, or the effect of having the capacitor here, prevents us from seeing a gate drain current as well. So we can cross that out, and that leaves us with answer A, which is a bias required on the gate. Well, we know that's where we control these devices, to reduce the drain source current, which is what we normally control from the gate, to 0. So that really does check out with what we already know. Let's take a quick look at the full license manual and see what that has to say. And we actually have this lovely diagram here of what looks like a depletion mode device, where we have the drain here, the source here, and a negative voltage being applied at the gate, and that's causing this this P region here to enlarge, and it will eventually get, with a large enough negative voltage, it will get large enough to pinch off this channel and prevent current from flowing here. So this will, pen's not on, this will grow, and that will stop current from flowing through here. And so that's what the pinch-off voltage is. It's going to pinch off this channel for electrons to flow. And so that matches up with what we're seeing with answer A. So let's go and check out the answer key, see if we got that right. And we see yes, of course, for question 16, the answer is indeed A. Thank you very much. I'll see you for the next one.